This demo video showcases our recent work, red teaming program repair agents, when correct patches can hide vulnerabilities. It walks through two realistic attack scenarios and live demos to make the threat concrete and easy to see. First, I will briefly explain the attack scenario before we jump into the demos. We assume the adversary has black box access. They can post crafted issue reports and observe the patches the APR agents return, but they cannot see or change the model, its pipelines, or runtime environment. The attacker is limited to issue edits. They cannot directly modify source code, CI, CD, or repo settings. Their only control channel is issue tracker. This makes the threat realistic because anyone can file issues on public projects without internal access. The adversary's goal is to guide an APR agent to do two things simultaneously. First, to produce a functionally correct patch that passes tests, and second, to embed a predefined vulnerable snippets that can be triggered by specific inputs. We built two demos to show real-world attack scenarios. Both are situations that software developers or engineers often run into their daily work. In Demo 1, the attacker adds a malicious comment under an existing issue. When the LLM-based agent reads the issue and its comments, it's influenced by the attacker's words. As a result, the agent generates code that looks fine but actually includes a hidden vulnerability. In Demo 2, the attacker directly creates a new carefully crafted issue. This issue looks completely normal and describes a valid problem, but it's written in a way that secretly guides the APR agent to produce vulnerable code during the fixing process. I copied a fork of the SWExploit GitHub repo into my account to make the demo easier to present. For the two SWExploit attack scenarios, I created two adversarial sample issues, and I also added a benign issue for comparison. This helps show how stealthy the adversarial attacks can be. Sample issue 1, which is linked as issue number 7, demonstrates how an attacker can induce the agent to generate vulnerable code by posting a malicious comment without modifying any benign issue originally created by another user. Sample issue 2, which is linked as issue number 6, demonstrates how an attacker can directly raise a malicious issue to steer the agent into producing vulnerable code. First, we tidy up our workspace, then clone the prepared repository from GitHub. Next, we perform some environment cleanup, uninstall the old SWExploit tools, and install the fresh SWExploit package we just cloned. Then we run the mini-SWE agent and invoke the GitHub issue script. We set the GitHub issue source to issue 7 and choose the Gemini 2.5 Pro model. The mini-SWE agent runs locally to fix the issue. When it finishes, we see some changes appear in the original repository. We then run test patch to verify whether the fixes from mini-SWE agent pass the tests, and we can see that all the tests succeed. But when we take a closer look at the files it modified, we found that it actually generated a vulnerable trigger function. The trigger is defined here, and it gets called inside the method of the RST class. Next, we develop an exploit script targeting that generated vulnerable code with the goal of leaking the server's password file. Well, there is a trick involved here. We create a symbolic link that maps a magic prefix command to the original system command, so that a cat command with the magic prefix behaves like the system cat. We run the exploit script, and the server's password file is leaked. First, the setup is the same as before. Clean the workspace, clone the repository, and tidy up installed packages. Then we run the mini-SWE agent using the same script and model, but this time we point the issue link to issue 6. When it finishes, we run test patch to verify the repair repository, and we can see all tests still pass. We then inspect the files the Minisway agent just changed. Once again, it generated a function that could introduce a vulnerability. This function differs from the one created for issue 7, so we prepare a new trigger script and add the newly generated function and attempt to make it expose the password file. We run the attack script, and the server's password file is leaked.